studio here at the National Museum of Industrial History. And on behalf of the museum and the Steelworkers Archives, I would like to welcome you to Steel Weekend 2025 for a celebration of the people and the legacy of steelmaking in Bethlehem and in our region. This weekend we come together to honor the veterans who worked here in the Bethlehem Plant, and who they transported, they defended, and they built our nation. So once the second largest steel producer in the United States and the largest shipbuilder in the world, Bethlehem Steel was one of the most vital military contractors in U.S. history, supplying massive quantities of ships, armaments, and steel to the American and Allied forces in both World War I and World War II. The company's production was so central to the war effort that many historians uphold that we would not have been able to win World War I or World War II without them. But this important role in military production began even earlier, when Bethlehem was awarded the contract to rebuild the Navy in 1887, which prompted the construction of a new plant to support naval production. This construction included the No.2 Machine Shop. So it is my absolute honor to introduce my colleague, Mike Piersa. Mike is the historian here at the National Museum of Industrial History. He's been with the museum for over 2 decades and has been instrumental in the research and interpretation behind the museum's collections, as well as the restoration of historical industrial equipment, both at the museum and at other outside facilities. Mike graduated with a bachelor's degree in history from Moravian College and a master's in history from Lehigh University. He has been described as having not only encyclopedic knowledge, but also the technical know-how which brings this museum into motion. So please join me in welcoming Mike Piersa.
Thank you all for having me today. This is the first time I'm doing this presentation. It's a history focused specifically on No.2 Machine Shop at Bethlehem Steel. So we're talking about one building alone. There'll be a little bits of tangents where we have to contextualize it, but this is how to just stress how important this structure actually is and the people who worked inside of it. When we were discussing what to call it, I decided on surprises from the archives because I thought I was going to give a lecture on big guns and lathes turning chips, but there are actually some really interesting facts that I learned, things that people 100 years ago took for granted, things people 70 years ago took for granted, they saw in the papers, but things that we probably don't remember today. So hopefully you'll learn a little bit as we go along. Here we have a picture of the actual sign that goes along the side of the machine shop. It's exhibited in our hall display case. And this is what the machine shop looked like in 1917. You can see it stretched almost a quarter mile long, making guns or artillery tubes for the Navy, Army, Coast Defense. And then here is a shot from 2006 showing it almost completely empty, ready for a new use. The story of the machine shop actually gets started back in the 1850s with Charlie Broadhead. He purchased about 100 acres of Moravian farmland here on the south side, and he was trying to figure out what to do with it. So he approached one of his relatives who was a senator and said, "Can you get me in touch with Jefferson Davis?" Remember, this is before the Civil War, so Jefferson Davis was the United States Secretary of War, and he said, "Why don't we set up a government foundry here?" They thought it was a great idea, but they couldn't make it happen because once you start competing with government for where a foundry can go, everybody in the country wants to have a foundry in their own backyard. So that didn't work out. But the idea was always in the back of Charlie Broadhead's brain. So whenever he saw an opportunity, he would bring it up again. But in the meantime, he worked with Augustus Woolley, got Bethlehem Iron Company situated on the site, and the company started making iron rails for the Lehigh Valley Railroad. These are samples of what a typical government foundry would have looked like back during the Civil War era. Sorry. You can see a ladle here, big giant molds that are being filled to produce cannon. That was at West Point Foundry in upstate New York. And this is a sample of a Rodman gun built probably at the Fort Pitt Foundry out in Pittsburgh. So you definitely had major defense contractors in the mid-19th century in the United States. But as you can see, the process was literally pouring molten metal into molds, just like we did last night at Foundry Park. So that's great in some situations, but as the world advanced, at a certain point, those guns just literally could not handle the pressure inside them. So this is where John Fritz comes in. We're truncating a bit of this history just because so much of it is generic to the Bethlehem Iron Company. But John Fritz was their first chief engineer. He was there for decades. But he realized very quickly the inadequacies of the company. That's why he went and convinced them to stop making wrought iron rails and move into steel rails. That was the wave of the future. If you wanted to survive, you went into steel. And by the 1880s, he realized that you could not survive on steel rails alone. The guys out in Pittsburgh were making steel rails. They were selling to railroads beyond the Allegheny Mountains. This was the period of westward expansion, transcontinental railroads being built. So if you're making steel rails on the East Coast and you're shipping them to Pittsburgh before you even begin laying track, and usually hundreds or thousands of miles beyond that, you're at an inherent disadvantage. So you need something that was specialized to keep these eastern mills running. Fritz, as he quoted, said, "I could plainly see the end of the acid Bessemer everywhere," and that means the Bessemer process of making steel, where you take air, blow it through a bunch of molten iron, and it converts into steel. Because the company was letting every Bessemer ore body pass beyond their control, so they couldn't even get the raw material to make this type of steel anymore. And the company president, Alfred Hunt, was opposed to going into anything new. And he finally got to the point where he told the board of directors, some of you say, let well alone, some of you say, let well alone, I say that in this case, such a policy will be suicidal. So he got to the point where he told the board of directors, we have to change things or we're just not going to exist. And if you look at neighboring companies like Allentown Rolling Mill, who remembers them? You don't, because they're gone. They disappeared over 100 years ago. Now Fritz, he got around. He traveled all over the country, all over the world. And when I was traveling up in Boston myself, I was struck by this beautiful steam engine they have on display at the Chestnut Hill Waterworks. It's still there to this very day. You can go and visit it. And one of the things the Waterworks Museum is most proud of is the spotlight they put on the crankshaft that says, "Freed for Frederick Krupp, Essen, Germany, 1892. The crankshaft for that steam engine powering a waterworks for a major American city was forged in Germany. So if that doesn't make somebody's blood boil, I don't know what will. In that case, examples like that really got to John Fritz. So one day Fritz was talking to Charlie Broadhead, who was still in the area, still involved, and Broadhead never let that idea of a government foundry slip out of his mind. So Broadhead told Fritz that there was a lieutenant in the United States Navy, Jocks, and he was head of the secretary of the Gun Foundry Board, and the Gun Foundry Board had sent Jocks over to Europe to tour these plants that were producing steel guns and armor. Jocks actually got, this is like a miracle in the 19th century, he got permission to go into these plants which were previously secretive, got licenses for technology, but was authorized to bring them back to America and get the Navy to begin negotiating for contracts to have an armor plate and gun forging plant here. Because as Fritz knew from examples like that shaft, there was no place in this country that could forge a steel gun, nor even a 10-inch shaft for a big giant steam engine. So over in Europe, Fritz actually went on a trip in secret and saw a lot of these factories. One of the places he saw was Le Creusot in France. They had the giant 100-ton hammer. So this is not an exaggeration. Those guys are literally that big compared to this hammer. It's several times larger than the hammer we have on display in the museum. They would take the forgings from that hammer, take them to a big machine shop, and this is where things start looking familiar. Giant lathes that spin around, shave chips off of the tubes, and begin the process of assembling them into guns that you could put onto warships. It wasn't just the French that Fritz and Jacques saw. They went to Joseph Whitworth and Company in the UK, and this is what their machine shop looked like. They called it a fitting shop, but you're going to start noticing some similarities to No.2 Machine Shop now. And of course, the gun shop at Krupp in Essen, it was in Prussia, now part of Germany. Overhead cranes, very, very long buildings, machine tools arranged lengthwise, because you're making very long parts. These guns could be 60 feet long, so you want to have a very long building. Jacques actually published a book with a lot of his recommendations. Most of it was focused on the forging plant, because that was a big, exciting thing, but he did put some information about the buildings. It's kind of common sense, but he had He said they had to have substantial foundations, strong but economical superstructure, secure against destruction by fire. That's something that Fritz could really relate to, because in Johnstown, his 3-high rolling mill burned down. Well, the building around it burned down 3 days after it was put into use. And he was infuriated by that, not just because of the fire, but because of his critics going out to the press and saying Fritz's mill was only 3 days old, the building must have burned down to cover up the failure of the mill, when in fact the mill was a massive success. So from that point on, Fritz made sure any building he built was not going to burn down. That's why the buildings here are built of brick, steel, and originally had slate roofs. Jackson also carefully considered lighting arrangements. So again, you look at No.2 Machine Shop, big giant windows, what we call a clerestory in the monitor, so you have additional windows, and there are even skylights at one point in time. And dimensions suited to the most convenient use of the tools, but which avoid wasted space under cover. So if we go back to the Bethlehem Iron Company in 1882, this is what it looked like. Our building that we're in now wasn't even built. That would be roughly right about here, where the word containing is at. You had the stone arches of the steel rail mill, the blast furnaces, albeit an earlier generation were still on the same basic footprints. And you had open fields here, railroad tracks, and even in this direction, another blast furnace. But the machine shop was this building here, 253 feet by 64 feet. So that's great for doing in-house work, building steam engines, but you're not going to be building guns that are 60 foot long inside a 253 foot long building that's already full of other machinery supporting the plant activities. So John Fritz went to the board of directors, basically told them it's now or never, and finally got the board to agree. Wilbur told Fritz, we will build the plant. So in 1886, Bethlehem Iron Company actually contracted with Joseph Whitworth and Company for machinery and know-how. This was before they got the contract. They were that confident in it. One of the questions the board asked is, what happens if the government doesn't award you the contract? And Fritz said, we'll have so much work from other venues that we won't have to worry about losing government contracts. But they got the contract anyways. They won both the armor plate and gun contract, and that's a copy with the Secretary of the Navy's signature on it right there. So they got to work building this plant. A lot of the documents we find are related to the armor plate plant and the forge, because the forge is where you have the big hot metal. That was the exciting thing, the 125-ton steam hammer. But the actual machine shop is where the fine work took place. So this is a cross-section that we actually have in our archives. You can see from here to here is 60 feet wide. Total width of the building is 116 feet wide. And then the initial incarnation in late 1880s was 641 feet long. For the technical people, look at the overhead cranes here. They're actually made of a lattice work, and they're pneumatically powered. That means compressed air power the cranes. The electric cranes that we have in the building now, and even in our museum building here, are a later generation. But they quickly advanced and installed those. So by World War I, the cranes were electric. The machine tools were powered just like you see in the Smithsonian display outside, with line shafts. So these circles here are actually pulleys that spin around and transfer motion via leather belts to the machine tools below. Now, what do machinists actually do? Is anybody here a machinist? Pretend machinist. So what the company would do is they would send the rough forgings from the press forge, and this is a sketch from the Industrial Archives and Library showing what the forging would arrive looking at. It looks round to us, but if you're in the Navy and you're going to be firing shells through this, you want that tolerance to be down within half of the thickness of a human hair. So a rough forging that might be off by an inch or two is not going to be sellable to the Navy. So a machinist has to take that forging and put it onto a machine and do whatever operations are required to make it into a precision part that can interchange with other pieces. In this case, this is the rough machining that they're giving, so you can actually see the dimensions down here. 3 1/16 inch, 14 7/16 inch, 264 5/16 inch overall. So imagine trying to cut a piece of lumber that precisely today. I don't know if I could do that good with the tools I have, but doing it with a giant piece of steel weighing, let's see, 17,200 pounds, that's a real achievement. So how did you become a machinist? Depending on the time period, you could go to a Votech school. That was often a good start. You could go to night school, go to correspondence school, like International Correspondence School out of Scranton, but you also need hands-on time on the machine. So a 4-year apprenticeship was very common. That's how the master machinists in Bethlehem got their start, by working with somebody who was already a master, staying with them for 4 years, learning every machine tool in the shop. And as your final apprenticeship project, you're often given something like this, which was a retirement gift for Charles Sanchez in 1971. He was a foreman in the shop, and to honor his service, they gave him a miniature version, and we have this on display in the case up here, of a gas engine piston and piston rod. That was one of the products they made in the machine shop. But the important thing, besides honoring honoring Charles, was that this was a product made by the apprentices to show off their skills. Now, you saw how small that apprentice project was. This is how big some of the pieces were in real life that they were working on. This is a worker standing right here. They had a lathe that has what they call a faceplate. That's the part that spins around that you attach the work pieces to, 10 feet in diameter. And obviously it wasn't big enough, so some of the lathes they actually blocked up and made them even taller. And they have a giant crankshaft on here, probably for a steam engine. One of the proud achievements they actually put in the newspapers was for the trolley company in Baltimore. The crankshaft broke on the engine that powered the electrical generator. So they sent a custom order to Bethlehem, and in an incredibly short amount of time, like days, they were actually able to do the forging and machining for a crankshaft to replace that generator and get the trolleys back in Baltimore running reliably. So it wasn't just lathes, they also had planers. This is later, they call it planer miller, where this big bed goes back and forth. And we actually have an earlier version of this in the museum, that big green piece with the wavy arc that goes like that with a bunch of little circles in it under the line shafting. So this bed goes back and forth, and you can see it cuts linearly like this. A planer would have a piece of steel that would shave it away very slowly. A planer mill has a revolving head around it that allows you to take a wider cut. They also had drill presses. So who has a drill press in their garage? Okay, some of you do. Do you put pieces on the drill press, or do you do what Bethlehem Steel does, because everything is so big, you put the drill press inside the part you're machining? They would literally pick these things up with a crane and move them wherever they needed to. So what they actually made in the shop that became famous for were big guns for the Navy and Army. This is an example of one from their 1904 catalog. It's a 12-inch gun on a disappearing carriage. So you can actually see the facts about the gun. Weight 1,000 pounds for the projectile that would be shooting out of the gun. Elevation, a lot of technical information, weight of the carriage alone. This is where things get mind-boggling. This is not the gun, it's just the carriage, 376,500 pounds. Figure the average automobile might be, what, 4,000 or 5,000 pounds? And you really get a sense of just how massive this stuff was. And this is the 1890s they were doing this. Next, we were actually able to go to the Canal Museum and look through some production records they have and see what were they actually building in the 1880s and 90s. They had, of course, the big guns with custom breech mechanisms. They did every little part here, so it's not just a big gun forging that's spun down. It's the breech, it's making the gearing, making the handles, everything you need to make this gun function. They started by selling semi-finished guns to the United States government. They were sent to the Washington Naval Yard and Waterloo Arsenal for finishing. But by 1900, Bethlehem was making the entire guns themselves for the United States government and for foreign governments. But they also did a lot of other neat things. So I'm just going to highlight a few of these. Armor for the USS Iowa. This is the 1890s version of the Iowa. Double-turret monitors. So think of like Monitor and Merrimack. They were still transitioning to the battleships in this era. Heavy shafting for battleships. Sugar mill shafting. That was a big business. Is sending machinery down south and overseas for sugar mills. And what really surprised me is you have this giant machine shop making things 60 feet long, but then they also have clients like the Norfolk and Western Railroad and the Baltimore and Ohio Railroad. They're making crank pins, which were literally like this big. But they took the work, and they actually, you keep on seeing crank pin after crank pin in these records. And Bloom Meal Shaft, Lackawanna Iron and Steel Company. That's interesting because Bethlehem Steel later took over that company, so they were selling to their predecessors. This is what the logbooks look like right now. So it's really a miracle that these things survived. But we're able to go in and read what they said on them. Now, John Fritz retired in 1892, and the machine shop kept on running. But by 1898, Bethlehem Steel was hiring a management consultant, and they hired Frederick Winslow Taylor to do a job that was described as giving that shop a brain commensurate with its size. That's a picture of Taylor there. He's also the same guy that we honor in the pig iron interactive, because he was there with the stopwatch timing the workers, how long it took them to load pig iron in the railroad cars, how long they would take a break for, and therefore what the bonus should be set at to spur them to do a little bit more work. So it wasn't just standing there with the stopwatch timing workers. He was actually hands-on, and we know he was hands-on because company records told us he literally ruined 3 lathes in the machine shop doing experiments. So in 1898, he worked with Monzo White III, and if I go too long, let me know, but these people are really fascinating. Monzo White came up here from New Orleans, was a real Southern gentleman, and then you have Frederick Winslow Taylor, who was like a New England personality, lived in Philadelphia, but they worked together, and they realized that if they could get the lathes to turn faster, they could increase their production. But to make the lathes spin faster, you have to be able to have cutting tools, which are these little pieces of steel, like the size of my finger, maybe 2 fingers on a lathe like that actually shave away the metal as it spins. So you can see these chips it produces. They very quickly realized that the tool steel they were buying was wearing out, and that it could only turn steel at a certain speed before it overheated. So they started doing experiments on the steel, and they eventually figured out, this is like within 8 days of working together with White, that if you heated the tool steel to the white hot temperature, cooled it down in a blast of air, and then dumped it into oil, it would be much harder, could last longer, and then you could spin the lathes at twice the speed and double your production. So they finally got the technique perfected and showed it off in Paris at the 1900 World's Fair. They actually brought the tool steel, they had lathes set up in Paris and did demonstrations there. And Bethlehem Steel was able to get into the tool steel business. And that's one of the reasons why you have another portion of this plant here, Alloy and Tool Steel Division, which specialized in making that product. But this was truly revolutionary until the time of carbide tips for machine tools. High-speed steel is how you actually did the cutting of the metal. And it was all pioneered here in No.2 Machine Shop. Next thing I want to go to is a few more of these customers. Again, this is a truncated list. You find more railroads, you find people like William Todd, who built giant rolling mill engines in Youngstown, Ohio. Hughes and Phillips, which built steam engines in Newark, New Jersey. Union Iron Works, another predecessor company on the West Coast they were selling to. Drive axle for Southern Pacific Railroad. So this was truly a national market that they were serving. And then the one that I got a kick out of was selling to Fraser and Chalmers and Edwin P. Alice. This was in 1901, and what happened to Alice and Chalmers later that year? They became the giant Alice Chalmers company we all know today. Now, the other thing Frederick Winslow Taylor did was he worked on instituting a bonus system. This is a quote, his attention, this is regarding the workmen actually running the lathes. He said, his attention closely fixed on the work before him, as every move must be made to count. He thus has no time for dreaming, which was no doubt the cause of many errors. The conditions of the machine is vastly improved. So by 1902, they were producing about 2.7 million tons of steel going through the machine shop, which is about 2.5 times the figures from about 2 years before they put that bonus system into place. So if you get bored, this is only going to be 1 or 2 slides, but this is what the workers actually had to go through. They had to have an observation card. It would record the man's name, number, time taken, and then they would actually go through and compute against the master card that they had about how long the job should take. And then these are all the calculations here. They would go through and figure out how much overtime he worked. He would get a certain rate for overtime, and then calculate his entire bonus out. In this case, the guy worked 12.5 hours long for a day, and got a 74-cent bonus. But for 1901, that's not bad. Now, safety. We can't do a presentation on history of machine shop number 2 or any industrial building without look at safety. Now, this may seem like a lot of accidents, but when we look at a shop that had 1,000 people employed in it, and think about what they were doing. They were working on the bonus system on piece rate. If you're getting paid for the extra steel you turn out of that shop, you don't want to have an accident because you're losing money then. So it's actually a very by my opinion, a safer shop than I expected. There were, of course, accidents, like a gun tube fell on somebody's head, and then that was happening because he was unloading a railroad car. Another guy got crushed between railroad cars. Electrician got shocked. And then the one that I'm lucky hasn't happened to me, a worker got a finger fractured because somebody was holding a large wrench, which they were using a sledgehammer to loosen, a heavy mallet. He got hit, taken to St. Luke's. And then every once in a while, they had a machine fail, so that machine actually had a part break and collapse down there. And that's a regular arm drill press. So they got their money's worth out of these machines. Strikes, they did happen occasionally. 1910, they had a strike that started in No.4 Machine Shop, which would have been out in one of these parking lots out here. The strikers actually walked to No.2 Machine Shop, but the policeman permanently stationed at the shop stopped them. There were strikes in the 1950s. This is a sample from Charles Sanchez's picket duty book. So when these guys went on strike, it's not like they went on vacation. They were actually out there protesting, getting their point across. And they did a good job of that because they actually instituted changes. But what also is interesting at the time of the strike is the reports that give information about the shop. It was almost its full length by then, 1,467 feet long. It grew about another 50 feet or so later. And they were putting out about 6 million tons of finished and rough forgings per month through that shop. And it also breaks down, the assembling plant was on the eastern end for the guns 6 inches and below, and the west side was used for the government inspection of finished ordnance. Now, it wasn't all work, there was some fun in the shop. So as you're going to hear, at 2 o'clock today, the company had a band that played. So from this old newspaper article, we know that the boys in the shop decorated the shop elaborately with flags, and the noon hour members of the Steel Company band appeared and played patriotic selections going from one floor to the other in the elevator. They also had a sports team, and this is a ranking of how well they performed. So your arts department won 93 games, lost 27, and No.2 Machine Shop is dead last. They won 15 games and lost 105.
15 wins and 105 losses.
And then every so often there were floods in the Lehigh River, and this is one thing that I never would have expected. Every building was submerged except No.2 Machine Shop. On 2nd Street, several hundred foreign families were rescued by means of rafts, and the people, including women, some of whom had children only a week old, were sheltered by the Bethlehem Steel Company in Machine Shop No. 2. 1910, they began an expansion program. That's when the erection floor was added here. That's where they assembled the battleship guns. And the famous photographs we still see circulating even on Facebook today. These are dimensions of the building. So this was added to the north side. And a lot of this is still here today. You can actually look up, see that oculus. And Piersa, it's just a massive open space. Later years, the turret assembly areas were dug down to about 15 feet deep, and they used them for hydrostatic testing. That's when you pressurize a vessel with water and see if there's any leaks. If you do it with something like compressed air, the force of the air might cause it to blow apart. But with water, you're theoretically not going to have a very major problem. But one time, they were doing a test above ground. The head popped off and landed 3/4 of a mile away. So they decided to do those tests underground in that portion of the machine shop. That way, if something did fail, it didn't go flying and kill somebody. 1915, this is in the throes of World War I in Europe. They're selling a lot of munitions and guns to the Allied powers. They actually added a 4-story extension here. And by 4-story, each story is about the height of a story in the museum here, with an overhead crane. So each floor was well equipped to handle machine tools, cranes. And there are actually openings in each floor, so you could hopscotch your way up from the ground floor up to the top floor with very heavy pieces. And the floor loading on those was 500 pounds per square foot. 1918, you're going to recognize this name today. No. 8 Machine Shop was placed into service because No. 2 Machine Shop just couldn't handle all the work by then. No. 8 Machine Shop eventually became No. 1 Machine Shop, and that's still in business today, just next door to the casino with Lehigh Heavy Forge. Now, when Fritz first got the idea for promoting this forge plant to the board of directors, there were about 38 ships in the United States Navy. But by World War I, they had 774 ships, and you can only imagine how many of those were fitted out with Bethlehem guns and armor. Now, what was especially pivotal for the shop was what happened after the war. In 1922, on February 9th, Washington Naval Treaty was signed. That essentially ended the production of steel battleships in the United States for several years. So the shop went from bustling to almost a standstill. Like, it felt like a standstill, it wasn't literally a standstill, overnight. The armor plate that was almost done was shipped to government warehouses. The work that was in progress was actually scrapped, and they had to figure out other products to make. So you saw that they still had a pretty good customer base for making crankshafts and crank pins. So by 1923, the tonnage had decreased, but the number of parts had increased, so they must have been making more parts that were just smaller. 1929, they started bouncing back a little bit, and we don't have the figures for World War II, but we know things really took off then. So one of the interesting things they made during those interwar years was a product inside No.2 Machine Shop called the Bethlehem Auxiliary Engine, or Booster. So this is a steam locomotive on the Norfolk and Western Railway, and behind it are what they call the tender trucks. Normally these are just wheels that are unpowered. They would just be dragged along by the train. But Bethlehem had the idea that if you have a big enough boiler, you can pipe your steam to these back wheels, put steam engines on them, put rods that connect each wheel, and except for these little guide wheels, every wheel on the engine could be powered, and you get a boost of power on startup. So that was actually a very popular product in the 1920s. World War I, the workers were back at work at full force, and they got the famous Army and Navy Year Award. But what astonished me was the date of the award. November 26, 1941. They knew war was on the horizon, and Navy was really proud of what Bethlehem was accomplishing and gearing up for what was next, which was a ship a day. Throughout the yards, Bethlehem had from coast to coast. Remember that figure, under 1,000 ships in World War I? The United States Navy had over 6,700 ships by Victory in Japan Day 1945. So this place was working around the clock, 3 ships, 30,000 workers, over the entire plant. World War II was also a time where the government was actually paying for some machinery. That's why you could go into the shop and see things like this grinder that says US Navy on it, the charging machine, which worked the electric furnace mill shop, that helps supply steel for the forgings. We actually have that on display outside. That has the United States Navy tag on it to this day. And the Navy was really diligent about the quality of what they were getting. They had inspectors on site. This guy looks like he's taking ultrasonic thickness readings of the roll or tube there. And this is a sample from the Industrial Archives and Library of the reports that they would issue. You can actually look at this. And this is a forging history, so it goes through the complete history of this barrel, from the press to the finished product. And we can read down here, Brunel at DN, that means they were taking a hardness test for this at DN, which was a code name for No.2 Machine Shop. Also, the acid S test here at No.2 Machine Shop. And the actual product was then shipped out to Milwaukee, Wisconsin for the Fall Corporation as part of their war effort coordination. So it wasn't just Bethlehem Steel selling products directly to the Navy. It was Bethlehem Steel supplying to the Navy, the Army, other suppliers who then sold to the Army and Navy. It was really an incredible amount of material. After the war ended, they had to figure out, what do we do with this giant machine shop? There was always going to be some defense production in their mind, but they took advantage of that slower period to do things like build supplies for other plants. So over here we see a sintering plant being built for Johnstown Works. This is where you take coke dust, iron ore dust, put it together with a downdraft flame, and bake it into, they call it a peanut brittle-like material that would be fed back into the blast furnaces as an early form of recycling. Then you have a transfer car and transfer table for the 160-inch plate mill at Sparrows Point. So imagine giant steel plates, 160 inches wide, traveling down to these roller sets near Baltimore. That's what it was built for. And then in the background of the photograph, we have these little tiny open hearts charging cars, and we have 4 of them outside the museum on our narrow gauge railway today. But these look like they're wider ones, probably for Sparrows Point, which was a larger plant. I have a little bit of a trick question. If I told you about Bethlehem Steel Club number 1, who here would consider being a member? Pass. So Bethlehem Steel Club number 1 is something that was a complete surprise to me. It was one of its head honchos was actually a worker inside No.2 Machine Shop, and that was the communist cell that had infiltrated the plant. there were 25 or 30 communists in the steel company, and the delicatessen owner from Allentown infiltrated them as a counter-spy for the FBI, actually got them caught. They were tried, found guilty, but eventually released without serving any jail time. So when you said security was tough in the plant, they meant it. They were not taking any jokes. These guys were actually monitoring what the company was producing and presumably sending the data all the way to the Soviet Union. That's right. 1950s, the machine shop also saw upgrades being undertaken. So they installed a 20-foot vertical boring mill from Giddings and Lewis. Actually, don't quote me on that name. It was Giddings and Lewis was a horizontal boring mill. So a vertical boring mill, imagine a lathe that spins things around like this. A vertical boring mill spins things around, I don't know what I did there. Sorry. Let me fix this real quick. We'll get back to where we were. Yeah, this works better when you have a little kid in the audience and you can tell them to spin around in a certain direction to visualize what these machines did. But we'll get back to the slide.
Must be absolutely brilliant.
Sorry, let me get rid of the survey too.
That's fascinating. I didn't know that first.
Wow.
That one guy.
Okay, thank you for bearing with me. Almost there. And again, with the amount of material on this talk could have gone on for 3 hours, so I actually did try to limit what I'm presenting here. Vertical boring mill, so you have a piece of work on the spinning table, so it spins around on the vertical axis like this. And then they have tools that come down from the side and machine it. Horizontal boring mill, the piece of work that you want to machine is on the table, and then this big arm comes with a mill head that spins around just a little bit, like my hand does, and it'll shave away like the edge of a piece here. And you can also bore into it, and you can actually make some very sophisticated parts on those machines. They actually installed a couple of what they call numerically controlled machines. That's the predecessor to computer control. You would have a tape, which is a punch card code like you have on the looms, that would go into the machine, and it would tell it automatically what kind of function to perform. You got into the atomic age with Bethlehem Steel. So by 1960, they had 166 machines in production use on the shop, covering 10 acres of space, and they're making things as diverse as counterweights for missile launchers and nuclear heads for nuclear reactors inside this 1890 building. And I can imagine some of these nuclear reactor heads might still be in service to this day. Now the workers on the job didn't necessarily know what they were making. They were just told it's a nuclear part and make it to the drawing. But you can see this part is easily, what, 10, 12 feet in diameter, but they still have hold a tolerance of 1/1000th to 1/2000th of an inch. As the plant wound down, they transferred operations to No.2 Machine Shop, but they also allowed photographers from the historic American engineering record to come in, and these are reviews from Joseph Elliott showing what the shop looked like in 1992. You can see that that vertical boring mill is still in service. The planer mill is still there. A lot of internal company parts there. You can see the B logo, meaning that was made there in Bethlehem in the foundry. And this workers were down about 200 people in the 1970s. And then by late early 1990s, they were using the shop primarily for storage and began clearing it out. At that point, the company, and there was people in the audience who can speak to this a lot better than I can, were looking at what you can do with this building. So one of the first things they did was make sure they got what they needed out of it. They moved some of the machines to another operation where some of them are still in service to this very day. Other ones were sold, scrapped. Some of them were set aside for the museum. So I think this is the first time some of our museum people are going to see this, but on the very top floor of the museum, we actually have a battered melting furnace, a triplex pump, and a few other devices. So this is what the shop looked like in 2006. Looking down from the second floor, looking into that erection bay where those gun turrets were assembled, and even up onto the top floor, as you can see the crane on the upper floor and the very top floor with those beautiful skylights. And then this is what the view looked like back then. You can look towards the blast furnaces, Hoover Mason Trestle, Philadelphia, Bethlehem, and New England Railroad Locomotive Repair Shop, Lehigh Heavy Forge, and today this is where the hotel is at for the casino. After the plant shut down, there were several ideas about what could happen to the plant. The first one was actually building our museum there. So Bethlehem Steel Corporation donated our building that we're in right now, the electrical repair shop, to be the preview center for the museum, with the idea that it could hopefully expand it to No.2 Machine Shop in the future. A deadline in 2010 was missed, so that wasn't able to happen with the casino coming into the picture. So the casino initially proposed a Bass Pro shop, which you see renderings of here. Then Bass Pro merged with Cabela's. There's already Cabela's 45 minutes or less away in Hamburg, so that fell through. In 2019, a water park idea was floated. The pandemic hit, and that idea sunk. And now we're looking forward to hearing what might be next for the machine shop. That concludes the talk. We actually have a slideshow we're going to air in the background as I take questions.
Wow, wow, wow.
Any questions?
Mike, excellent presentation.
Thank you.
How long did it take you to research that and to follow up? Do you have any plans on publishing this stuff, or
That's
at
a-
least putting it together in a written format?
That's a very good question. I'd like to publish it. I don't really have a good sense of timing on like the research because a lot of it was accomplished incrementally over a period of decades with background information. But I spent probably a good 6 or so days in archives just looking for material. And then I didn't, because I only needed a limited amount of information for the presentation, I didn't go through every single box that was there. I just tried to get the highlighted sampling. And key years, like I knew like 1918 was critical, World War II, of course. But really, I could probably spend another 2 months of like pure research on this if I want to have like a true like academic publication, even to be ready to put together. But I think that's something that would be a very worthwhile goal in the future, though, because there's so much material I didn't touch on, and a lot of stuff like I wanted to show off like the floor plans of the machine shop. But to go into the incredible detail of 166 machines, you almost have to write an encyclopedia about it.
Wow.
But I think the effort of detail should go into that, because at some point when development happens, you're going to want to know, what are you standing on? Is this a foundation for a lathe, a warring mill? Were you making a gun here? What happened on this spot? And in a lot of cases, we can say almost to the inch what happened here.
Wow.
And these are all photographs from the National Museum of Industrial History Archive. And it's really amazing the variety of products they were making when these pictures were taken in the 1940s and 50s. You'll see a lot of names like Lowy Hydropress. That guy is standing on the saddle for the Delaware Memorial Bridge, turning a roll. It looks like a roll in the lathe. Specialized saw blade that they developed for cutting into a casting. So that guy is probably 12 feet off the ground. And I'm not going to narrate every single one of these, but if you see something, ask a question.
Amazing. How many workers in at one time, do you think?
Mike, I think there's a question.
Mike,
Yes.
how many workers you think would be in at one time?
It really depended on the time period. 1970s, I had about 200. World War I era, a little bit over 1,000. But we can actually go through like year by year, and at least in some years, like 1892 to 1929, we have the employment figures for most of those years. But it's really amazing. Think of a building 1,400 feet long and 1,000 workers, like almost every foot and a half or so, less than that even, you'd have a worker somewhere in that building, like statistically speaking. They're, of course, congregating in certain areas. But this was an incredibly busy place, and of course, spread out over 3 shifts. It's going to give you some more distance. But for a machine shop, it's just mind-boggling how many people were working in this thing. And then, of course, add the additional stories and the shift work that they were doing. These machines, the big ones on the first floor, they didn't want them sitting idle. They wanted them to be running and making chips and being productive. So this was really a beehive of activity.
Wow.
In the back?
What was the climate in there? Was there any heat or cooling?
There was no practical cooling. There were probably fans at some point in time, like you would aim like at specific people or places. But for the most part, it would be heated because as a machine shop, metal grows and expands. So if you have a machine shop on a winter day and you don't have heat and it's 32 degrees, there's actually formulas you can look up to figure out if you turn the heat on, how much is that shaft going to grow? And if you're making a shaft 60 feet long, and you're going from 32 degrees to, let's say, 65 degrees, you're going to have a measurable growth on that shaft, and that's going to throw off your dimensions. Like, what are you measuring? Are you measuring it cold, or are you measuring it hot? So you have to have a nice, stable, uniform temperature, so there would have been heat in the shop. Yes?
I used to sell real estate here in Bethlehem in the Lehigh Valley, and I often went into homes where the main beam was an I-beam, or they had a patio that was an I-beam, and it's, as a matter of fact, there's a building not too far from here. That's all it is a 40 by 40 foot garage, but it's got two 40-foot I-beams across it. Did employees get discounts on buying those I-beams, or were they leftover material that people could pick from? How did that go down?
I think it probably depended on the year. If there's anybody more qualified than I who would like to speak to it, feel free to raise your hand. But we do know there are certain situations where employees did get free steel. And then, yeah, of course, you really don't want to hear this, but they also know how to take things home. There's
I could
I
take
kind of thought there was so much steel around there.
yeah, there's a famous story of one worker who had a wheelbarrow in his back of his truck, and
my dad was a rigger.
this guy asked him, like, hey, why do you have this wheelbarrow in your truck? He was like, oh, I have something for my garden I'm bringing home, or I forgot it in the truck or something. And this happened like day after day, and they finally went and figured out this guy isn't hauling stuff back and forth just like forgetting to empty his truck. He's stealing a wheelbarrow every single day.
Oh my God.
So they have their ways of getting things out, and they can also get passes for scrap material. So it might have been a beam that was off chemistry that they didn't want to sell because it was a customer that was really finicky and they're only going to buy this particular grade of steel. The warehouse might have been full. You come up with any imaginable excuse, and you might be able to get a pass for that material to come out. And sometimes it was just outright theft. Yes?
Mike, the number one thing you have to know, if you ever worked at Bethlehem Steel, if you weren't paying attention to what was going on around you, you wouldn't last very long before you were laid up somewhere.
That's absolutely right.
It was, if you went into a place like the beam yard, where you're running beams back and forth, going from one area into the next bay alongside, it used to be at one time, these rollers would just take this stuff right through, and there was no way to safely cross the other thing. A lot of guys got killed down there, just getting hit by beams going up and down within the various areas there. But the problem was, if you weren't paying attention, boy, you were really in trouble. In fact, the last couple of years that it was in operation, Bethlehem Steel, and I have to tell you this in all sincerity, we stopped having custom-made foremen in charge of safety. Instead, the union turned it around, and the union was in charge of safety. And we knocked off 75% of the accidents as a result of that.
Congratulations.
But
Wow.
when you're in that beam yard, they actually refer to it as the chop shop of Bethlehem Steel. That's how many accidents they had there. I mean, I was part of that in the electric furnace. I had a very heavy 100-ton crane. It stopped working. I opened the door on the crane, and the thing exploded in my face.
Wow.
It took my hair off all the way around from the bottom of my hat. It gave me a second-degree burn on my face. And I'll tell you what, I'm not going to tell you what ended up with, but something wasn't right after that. I think I went in my pants.
It's amazing that's all you did.
But I was out of work for a while. It wasn't that bad. And I'll tell you what happened is parts inside that crane where that switch was were on there for so long, and I was on a crane and nobody else knew it, that it was set up the wrong way, the way it was wired. And when that wire came on, and boom, it was just like a big light bulb went off. Boy, it got me good.
Dad fell from the
Wow.
crane.
And
I'm glad you're still here with us.
just a really dangerous operation.
He
But
healed up
people
and he
keep
went back
coming
to
back
work.
for the very simple reason, it was one of the best paying places in the Lehigh
He
Valley.
was born in
And
1910.
I was glad for everything Bethlehem
I
Steel
would
did for
think
me.
he worked there from.
But one of the things, because I was a grievance committeeman, which is like a business agent in all three locals,
Went there.
I used to give lectures all over the plant about what
Over 30
is
years.
going on and what you want to make sure doesn't go
That's
on.
my guess. I mean, I
So
was the youngest.
I
of five.
ended up being the only guy down there that
33
worked in all three locals, 2598,
Now, that would have
2599, and
been
2600.
twice.
And every place
Not
was,
the 13 weeks.
it was
vacation.
a bomb waiting to explode. You had to be so careful. It wasn't even funny.
I'll tell you stories.
I'm glad you got the message across.
I think I did.
Thank you for sharing that.
Yep.
It's,
Do we have any other questions?
Because he,
Hey, Mike.
Yes.
In your research and all this, I think what I look at all these pictures over all this time and I go, well, how did they move some of those big gun turrets? And how did that get moved? Is it just rail or, because some of that stuff was really big.
Oh, absolutely. They would have specialized flat cars. There's a picture somewhere in here, perfect timing, of one of those flat cars that actually has a hole in it so you can get a larger piece in it. They would have, I don't know the year they came out, but today we call them Schlabel cars, where they actually have a depressed center and they can actually shift the car from side to side to maneuver around obstacles alongside the railroad line. So they had different techniques of making these big things move, and taking them apart and reassembling them was also a big part of the equation. But they had trains in the shop that could do 70 tons each, and it was not unusual for them to have to work together. One craneman and one crane go down the length of the part, have another crane, and you can get a 140-ton pick out of that. And
not very.
under certain situations, you could even increase the pick based on whatever engineering they could calculate the crane could handle as max, because they of course have margins of error built into these ratings, so you could usually up them a little bit. Yes?
Can you tell us about your big gun bus excursion coming up?
Oh, that's a great point. Thank you for reminding me. So since Bethlehem Steel built big guns, and we only have one gun on display here in Bethlehem, and which when we were going to drive by it on this tour, we decided to book a bus tour for October 26th to go to Sandy Hook Proving Ground. Our friends with the Army Ground Forces Association offered to give us a private tour just for our museum members of what happens on that. Of what happened at that proving grounds, and showcase their work and one of the gun batteries that they've been meticulously restoring. They've got to the point where they can do everything except actually fire a 6-inch gun. Disclaimer, the gun that they have is a mid-bail gun, but the same technology and the same processes would have been used here at Bethlehem. So we can actually go and see a gun drill happening, loading it with ammunition, aiming it, turning it around, going the chemical decontamination chamber and actually get a blast of air on us, as if it was the middle of the Cold War and we were being attacked by the enemy. It's really going to be a very interesting experience to see that. 16-inch gun up at another location in Monmouth County. And I think you guys would all really enjoy seeing how these guns were actually used, and people who have some hands-on experience in the modern day restoring them and making them come as close to life as possibly they can.
Is there a gun over there in front of the High House?
Yes, there is. There is a 14-inch gun that was built for the USS Mississippi on display in front of number 3 High House.
Yeah.
So to get here, you would walk towards steel stacks, continue along the road under the Hoover Mason trestle, go towards the river, turn right, and then you'll hit this tall building made of brick and extends over the top of the Mincy Trail Bridge, but just before the bridge, and directly in front of that is a 14-inch gun on display.
Yeah. Yeah, it's right there. People don't know that.
Great. Well, thank you all so much for coming, and be sure to enjoy the hall display case with more artifacts from the machine shop.
Thank you, Mike. That was wonderful. We appreciate you sharing your expertise with us. And if you enjoyed our lecture series this weekend, please consider membership or a return visit.